It's a sensation we've all experienced. A brilliant idea hits you in the shower, or you finish a friend's sentence before they even inhale. This lightning-fast arrival of intuition feels less like something we built and more like something we heard. Classical neuroscience explains this through a physical model, viewing the brain as a biological factory. In this view, every thought is churned out internally through a complex assembly line of chemical reactions and synaptic firings. This bottom-up process relies on a specific biological sequence. DNA creates RNA, which then synthesizes the proteins used to build and modify the neural pathways responsible for thought. But the speed of human thought exposes a significant loophole in that timeline. We can generate complex real-time responses in milliseconds. Meanwhile, the biological machinery of gene transcription and protein folding operates on a scale of hours or even days. The manufacturing process is simply too slow to account for the speed of human intuition. The biological hardware cannot build these thoughts from scratch in the time it takes for us to think them. If the brain lacks the time to manufacture thoughts internally, we are left with a startling alternative. The brain acts as a receiver, and the source of the music is somewhere else entirely. To find a mechanism capable of receiving an external signal, we must look past standard neurotransmitters and focus on subatomic structures hidden inside the neuron. This leads to the orchestrated objective reduction theory, or Orch-OR, co-authored by the physicist Roger Penrose. Penrose identified microscopic structures inside our neurons called microtubules. These cylindrical, lattice-like structures function as the brain's quantum hardware. Because of their microscopic scale, microtubules allow for quantum computations. These subatomic processes happen instantaneously, bypassing the slow chemical assembly lines of the classical brain. Operating at this subatomic level, microtubules provide the precise hardware required for the brain to tune into a universal broadcast. Connecting a biological antenna to the rest of the universe requires a specific medium, a bridge that links internal neural activity to external fields. These are human theta brainwaves. Oscillating between 4 and 8 Hz, they characterize deep meditation. This frequency matches Earth's electromagnetic hum, the Schumann resonance, at 7.83 Hz. Brain synchronization with this global field creates a stable channel for information transfer to our neural antennas. This channel allows the brain to tap into the background of reality, a state known in ancient philosophy as shunya, or the quantum void. This void operates as a field packed with latent and tangled information. It holds the potential for every thought before it is ever expressed. As the brain's microtubules interact with this field, they trigger a wave function collapse. The vast, formless potential of the void solidifies into a single, localized thought that we experience as our own. Human consciousness, then, is the localized result of this universal information field, translated through biologically synchronized antennas. Because this system relies on precise electromagnetic synchronization, it is vulnerable to interference. Common mental hurdles like writer's block and anxiety emerge as decoherence, environmental static that disrupts the receiver's ability to catch a clear signal. Meditation offers a technique for cleaning the biological lens, stabilizing the internal frequency until the static fades and the broadcast returns. The radio metaphor also changes how we view mortality. If you smash a physical radio, the music stops playing in that room, but the signal remains in the air. Physical damage to the brain represents the breaking of the receiver. The underlying signal, the information in the quantum void, stays intact, unaffected by the destruction of the vessel. We are not isolated thought factories working in a vacuum. We are the instruments, and the music is the universe itself trying to play a tune through us.